So in this video, we'll talk about the set theorem. So before we go into much detail, we need to define what a set is. So according to my definition, I say that a set is a collection of well-defined objects. So a set is supposed to be well-defined, meaning that you have to specify what you're talking about. For example, a collection of objects. So that one, there is no specification, so it means that it's not a set. So it's supposed to be well defined. That's what we call a set. So I have some a bit examples that we'll look at to differentiate a set and not a set. So these are the examples here. So if you look at the examples on the other part, it says on top there, it says not well defined or not a set. Then the other side, you shall see that there is well defined, which is a set. So the first example, it says a collection of tall students in your school. So if you look at the collection of tall students in your school, so you shall see that something that is tall to you, it cannot be tall to another person. So unfortunate that it's not defined, like this set is not well defined, so meaning that it's not a what, a set. But for it to be a set, it's supposed to be like a collection of those students of your school whose height is more than 180 centimeters. So that is a set. So a second one, again, a collection of honest persons in your colony. That one is not a set because it's not well defined. What is honest to me, it cannot be honest to other people. So meaning that it's not well defined or it's not specific. So for it to be a set, what you need to do is you have to say a collection of those people in your column who have never been found involved in any theft case. So that is a what? A set. Then the other one, a collection of interesting books in your school library. So if you look at that one, a collection of interesting books. So what is interesting to me, it cannot be interesting to others. So meaning that that is not a set because it's not specific. But for it to be a set, you need to say a collection of mathematics books in your school library. So that is a set. Then number 5, the collection of intelligent students in your school. That is not also a what? A set, because a collection of intelligent students in your school, that is not a what? A set again. Why that one is not a set? Because it's not specified or it's not well defined. So I can say is not a set. What is intelligent to me and what is intelligent to others is different, because others are good in terms of school, others are good in terms of football, others are good in terms of movies, others are good in terms of computers. So intelligent, it differs. But for it to be a set, you have to say a collection of those students in your school who have secured more than 80% marks in annual examination, that it becomes now a set. Then number 6, a collection of short students in a class. So when you say a collection of short students in a class, that one is also not a set. Why is not a set? Because one, what is short to me, it cannot be short to others, right? So meaning that that one is not a set and it's not well defined. So that one is not a set. But for it to be a set, it's supposed to be a collection of students whose height is less than 1.51 meters. That is a set. So the last one, a collection of interesting books in the school library. meaning that that's not a set. But for it to be a set, we have to say a collection of books in the library. So that is a set. So if you check at the differences, you need to know that a set is supposed to be well defined. That's what we call a set. So let's go to the other thing. So when you go to the other thing, you shall see there's a representation of sets. So there are two ways of how we can represent sets. The first one is what we call the first one is what we call the roster form, or what we call the tabular form. So in tabular form, in this method is a presentation by listing of all its what elements, separating by commas and enclosing in brackets, right? So that's what we call roster form. So in roster form, what we do is just we list the elements of the set, of the given set. So we just list the elements of the given set. So the good example is, if V be the set of vowels of English alphabet, it can be written in roster form as V is equal to A, E, or O. So that's what we call the roster form. Then example 2, if A be the set of natural numbers less than 7, then set A, it can be 1, 2, 3, 4, 5, 6. They're supposed to be less than 7, so we have to end at what? 6. So that's what we call the tabular form or the roster form. Then the other form of representation is what we call the set builder form. So when we look at the set builder form, in set builder form, what we do is, in this form, a set is presented by describing or stating the property satisfied by all the elements of the given set. So in short, in set builder notation, you come up with a statement or a property that would describe every element in the given set. So that statement is supposed to describe every element in the given set. So for example, let V be the set of vowels of English of alphabet. Then V can be written in the set builder form as X is such that X is a vowel of English alphabet. So that's what we call the set builder form or set builder form notation. Then the second one is what we call, let A be the set of natural numbers less than 7. So you can write it in this form, like X is such that X is equal to N. So there is supposed to be is equal to N here. Here between here. It's supposed to be is equal to what? To N. That's why you're seeing like that. Is it okay? And 1 is less than or equal to X. And X is less than or equal to 7. So that's what you supposed to do on that one. So let's also look at what we call the classification of sets. So classification of set, we shall start from what we call the finite and infinite set. So now the finite set, a set B is said to be finite if it has a definite number of elements, right? Or in another way, we can say a finite set is a set that has countable elements. So a finite set is supposed to have elements that you are able to count. For example, 3 members of a given set or 4 members of the given set. So we say that one is a what? A finite what? Set. Then the other one saying the empty set is also a what? A finite set. Yes, the empty set is also a finite set because you're able to count that there is nothing in a set. So we call that as what? a finite set. So in another way, we can also, the number of elements can be also be called what we call cardinality. So according to the definition that I have, I said the number of distinct elements in a finite set is called what we call cardinality. So a cardinality, it is the number of the distinct element in a given set. So what we call cardinality. So a finite set, it has a cardinality, but an infinite set, it doesn't have a cardinality. So meaning that it has unlimited number of elements. So it's said to be what? An infinite what? Set. So an infinite set, it's a set that has unlimited number of elements. So for example, we have x, we have a. So in a we have x is such that x is a natural number. So if you look at that, you shall see that you're having the natural numbers and the countable natural numbers. So meaning that set A is an infinite set. Then when you go to set B, it says that x is such that x is a student of your school. So if you look at the student of the school, you can able to count. So that one is a countable. So that is a finite set. Then we also need to look at what we call an empty set, or what we call a null set. So if you look at this example, which is A there, so you have A there, right? They're saying A is equal to what? X is such that X is a member of real numbers, and X plus 1 is equal to 0, like that. So they are asking, consider the following set. So is this set an empty set, or it's not an empty set? So for you to find out, what do you do? For you to find out, you need to solve this equation which is here. So you say x plus 1 equal to 0, then x is equal to -1. So if you recalculate, meaning that A has only one element, which is what? X. So if you check at A has only one element, which is X. Now if A has one element, which is X, now can we call set A as an empty set? The answer is no. So this one, it is not an empty set, right? How about B? The B says x is such that x is a number which is greater than 7. A number that is greater than 7 and at the same time is also less than 5. There is no number that is greater than 7 and less than 5. So meaning that B is the empty set. Then the other one is what we call the disjoint set. So a disjoint set, it's a set that has an empty set, or an empty set of intersection short. So if you have two sets A and B, so if the intersection set between A and B is empty, meaning that we call that as the disjoint set. A good example that I can say here, for example, so we have A, the element 1, 3, then 5. When you look at B, you have 2, 4, then 6, like that. So if you look at this, we have discovered that, do we have intersection elements of A and B? The answer is we don't have. So we call this as the what? The disjoint set. So, and the last one is what we call the singleton set. So a singleton set, it is the type of set that is having only one element into it. So a set is having one element into it. Just know that that is a singleton set. For example, here we have A is equal to 0 and B is equal to 2. So those ones are what are called a singleton set. Or in another way, we can say the cardinality is 1. Then the other example that I can say that is that x is such that x is an even prime number. So x is an even prime number. So it's supposed to be even, again supposed to be prime. So what is that? It's only 2. That is the only element which they have mentioned, or that is a number that can be even, it can also be what? Prime. So for today we can end from here. Let's wait for more examples or exercise.